Lucy is arranging 1 cent and 5 cent coins in rows. The pattern of coins in each row is as shown below. So in row 1, we just have a single 1 cent coin. In row 2, we have that 1 cent coin again, but we have a 5 cent either side of it. In row 3, we have row 2, which was the 1 cent in the middle, the 5 cent either side, and then we have another 1 cent either side of it. And in row 4, again we have 1 cent in the middle, then 5 cent either side, then 1 cent either side of that, and 5 cent either side of that. Part A says, draw the next row of coins above, continuing the same pattern. So press pause and have a go at it, and when you're ready for the answer, press play. The next set of questions are on the next slide. So here we have question B, C, D, E, F, and G. So again, press pause and try these, and then when you're ready for the answers, press play. So part A, draw the next row of coins above, continuing the same pattern. So we have row 1, row 2, row 3, row 4, and now we need to draw in row 5. So here we have row 5, and it's basically row 4 repeated again underneath, but a single 1 cent coin at the start and at the end. Part B. The table below gives the number of coins and the total value of the coins in each row. Complete the table for rows 4 to 7. So here we have row 1, which is completed, row 2, and row 3. Now we need to complete row 4, 5, 6, and 7. So we can see in row 1, here's row 1, we had a single 1 cent coin. So the number of 1 cent coins, there was one of them, and the number of 5 cent coins, there was 0. So the total number of coins in the actual row, there's only one coin in the row, and the total value of the coins is just 1 cent. So then for row 2, the number of 1 cent coins is 1. So we can see we've got a single 1 cent coin in the middle there for row 2. The number of 5 cent coins is 2. So we've got a 5 cent coin either side of the 1 cent coin. So we've got 2 5 cent coins. The total number of coins is 3. 1, 2, 3. And the total value of the coins is 11. 5 plus 1 plus 5 is 11. And then for row 3, here's row 3. The number of 1 cent coins was 3. There's 1, 2, 3. The number of 5 cent coins was 2. There's 1, 2. The total number of coins was 5. 1, 2, 3, 4, 5. And the total value of coins was 13. 1 plus 5 plus 1 plus 5 plus 1 is 13. Then for row 4, the number of 1 cent coins was 3. 1, 2, 3. The number of 5 cent coins was 4. 1, 2, 3, 4. The total number of coins was 7. 1, 2, 3, 4, 5, 6, 7. And the total value of the coins was 23. 5 plus 1 plus 5 plus 1 plus 5 plus 1 plus 5 is 23. Then for row 5, the number of 1 cent coins was 5. 1, 2, 3, 4, 5. The number of 5 cent coins was 4. 1, 2, 3, 4. The total number of coins was 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the total value was 25. 25 cent. 1 plus 5 plus 1 plus 5 plus 1 plus 5 plus 1 plus 5 plus 1 is 25 cent. So we now want to know about row 6 and row 7. So we could draw out row 6 and then underneath it draw out row 7 and then just do like we did, add them all up. Or we could have a look and see what the pattern is in the numbers. So the number of 1 cent coins was 1 and 1, then 3 and 3, then 5, so we presume it's going to be 5 again, and then 7. So it's all the odd numbers, but repeated twice. So 1, 1, 3, 3, 5, 5, 7, 7, 9, 9, 11, 11, and so on if we were to keep moving down. But we're only interested up as far as row 7. Now let's have a look at the pattern of 5 cent coins and see do we see a pattern. So we start off with 0, then 2, 2, 4, 4, and we presume it's going to be 6, 6, then 8, 8, then 10, 10, and so on. So it's all the even numbers, but apart from 0, which is the first term, it's twice each of the even numbers. So 2, 2, 4, 4, 6, 6. Then the total number of coins. So it was 1, then 3, then 5, then 7, then 9. So we are going up in twos. So 11, and then 13. And then the total value of coins, well, we start at 1, then we go to 11, then 13, then 23, then 25, then 35, then 37. So we can see we started at 1, we had 1 cent. Then we added on the 2 5 cents, we added on 10. Then in the next row we added on 2 more 1 cents, so we're adding on 2. And then this pattern repeats itself. So we add on 10, then we add on 2, then we add on 10, then we add on 2, then we add on 10, then we add on 2. So we get up as far as 25. So we add on 10 to get 35 and add on 2 to get 37. So if we wanted to continue this on, we would add on 10, add on 2, add on 10, add on 2, and so on. Part C. Complete the following sentences to state, in terms of n, the number of 1 cent and 5 cent coins in row n. Part 1. If n is odd, row n has something 1 cent coins and something 5 cent coins. So how many 1 cent coins, how many 5 cent coins? Part 2. If n is even, row n has something 1 cent coins and something 5 cent coins. So we know that there's a pattern and it repeats itself for each of the rows. So if we just take the first 2 terms, so the first 2 rows, so row 1 had 1 1 cent coin and 0 5 cent coins, and row 2 had 1 1 cent coins and 2 5 cent coins. So this is all we actually need to work this out. So if n is odd, so 1 is an odd number. So if n is odd, then row n has something 1 cent coins. So it has n 1 cent coins. So for row 1, it has 1 1 cent coins. For row 3, it has 3 1 cent coins. For row 5, it has 5 1 cent coins, and so on. So for all the odd numbers, whatever that n happens to be, whatever that row happens to be, so for example for row 7, it would have 7 1 cent coins. So we can state that if n is odd, row n has n 1 cent coins. And it will have n minus 1 5 cent coins. Because we can see we have 0 here, and 1 minus 1 is 0. Now, if n is even, so for example 2 here is an even number, so if n is even, then row n has n minus 1 1 cent coins, and it has n 5 cent coins. So we'll have a look at the 5 cent coins first of all. So for row 2, it has 2 5 cent coins. For row 4, it has 4 5 cent coins. For row 6, it has 6 5 cent coins. For row 8, it has 8 5 cent coins, and so on. So remember, we're just focusing on even rows for the moment. So row 2 has 2 5-cent coins. So row n has n 5-cent coins. And then if we have a look at row 1, well, there's only one 1-cent coin there, and that's 2 minus 1 gives us 1. So n minus 1 gives us 1. So we have n minus 1 1-cent coins. So these statements are true for any of the rows that we're talking about. So if the row is odd, let's say, for example, it's the 7th row, which this number 7 is odd, there will be 7 1-cent coins and 7 minus 1, which is 6 5-cent coins. If we're talking about an even row, let's say the 6th row, 6 is an even number, it will have 6 minus 1, which is 5 1-cent coins, and 6 5-cent coins. You can check this for any of the rows and it will work out. Part D, find the total number of coins in the 40th row. Well, the 40th row would be n equal to 40, which is even, so we can use this statement that we just worked out. If n is even, then row n has n minus 1 1-cent coins and n 5-cent coins. So the number of coins is going to be n minus 1 plus n. So that's the number of 1-cent coins plus the number of 5-cent coins. So we can just simplify this. N plus n is 2n, and then we just bring down the minus 1, and then we swap that n for 40, because we're interested in the 40th row, where n is 40. 2 times 40 is 80, and 80 minus 1 is 79. So there are 79 coins in the 40th row. Or, what we can do is have a look at our row. So this is the total number of coins in the row. So in the first row, term 1, it was 1, then 3, then 5, then 7, then 9, then 11, and 13, and so on. So we can write out that sequence, 1, 3, 5, 7, 9, dot, dot, dot. So we can come up with the nth term, which is actually what we did over here. That is technically the nth term for that sequence. So one way of coming up with the nth term is firstly by finding the difference. So we're adding on 2 each time. So we write down 2 and stick on an n. And then we go back by 2 to find the 0 term. So if this is term 1, then this is term 0. And 1 minus 2 is minus 1. So we stick on a minus 1. So the nth term is 2n minus 1. So term 40 is 2 times 40 minus 1, which again is 79 coins. So I'm going to now show you how to get the nth term using the formula that's in our formula book. So our formula in our formula book for the nth term, or Tn, for an arithmetic or a linear sequence is Tn equals a plus n minus 1 times d. So a is the first term, which is 1. So we swap that a for 1. Then we write out the rest of our formula, and then we swap that d for 2, the common difference. So we get Tn equals 1 plus bracket n minus 1 times 2. We bring down the 1 and the plus. Then n multiplied by 2 is 2n. And minus 1 multiplied by 2 is minus 2. And then we simplify, so we bring down the 2n. And 1 minus 2 is minus 1. And again, we end up with the nth term being 2n minus 1. Part E. Find the total value of the coins in the 40th row. So again, the 40th row is even. So we're going to use this statement here to help us. So if n is even, then row n has n minus 1 1-cent coins and n 5-cent coins. So the total coins for term 40, the value of them, is going to be the number of 1-cent coins multiplied by 1 cent. So that's going to be 40 minus 1, which is 39, multiplied by 1 cent. So there's 39 1-cent coins, and 39 multiplied by 1 cent is just 39 cent. And then the number of 5-cent coins multiplied by 5 cent. So there's 40 5-cent coins, multiplied by 5 cent. So 40 multiplied by 5 is 200 cent. And 39 cent plus 200 cent is 239 cent, or €2.39. So this is the total value of the coins in the 40th row. So that's one way to do it. Another way is to take our column, which is our row number, so our term number. So row 1, row 2, row 3, row 4, row 5, and row 6. And then take the column that has the values. So I've just put these two together, but this was actually on the left-hand side of what was given to us, and this was on the right-hand side. So I'll just show you that again for 1 second. So remember, this is the table that we filled in part B. So I've taken the first column, row number n, going 1 down as far as 6, and then I've taken the last column, the total value of coins in the row, going down as far as 35. And I've just stuck them together because I'm not actually interested in these other columns in the middle. So here we have the row number, n, 1 to 6, and then the total value of the coins in the rows. Okay, so I'm interested in the even rows. So 2 is an even number, and 11 is the first term. Then 4 is an even number, an even row, and 23 is that term. And 6 is an even row or an even number, and 35 is that term. So I'm going to create a sequence with 11, 23, and 35. So I have 11, 23, 35, and I want to find the nth term of this sequence. So one way is to, first of all, find the common difference. So between 11 and 23, we're adding on 12. Between 23 and 35, we're adding on 12, and so on. So write down a 12, stick on an n. Then if 11 is the first term, term 1, I go back by 12 to find term 0. So 11 minus 12 is minus 1. So I write down the minus 1. So my nth term is 12n minus 1. I'm going to swap that n for 20 with brackets around it to get term 20. The reason I'm doing that is that 40 divided by 2 is 20. Remember, we were interested in the 40th row, so the total value of coins in the 40th row. But since in this way we're only focusing in on every second row, half of 40 is 20. So 12 times 20 minus 1, again, is 239 cent. So I'll just show you the other way to get the nth term of the sequence using the formula. So our formula for the nth term of an arithmetic sequence, a linear sequence, is Tn equals a plus n minus 1 times d, where a is the first term and d is the common difference. So 11 is our first term. I know it says term 2 there, but if we're only interested in the even terms, the even rows, then 11, 23, 35 is our actual sequence. So 11 is our a, 11 is our first term. So we bring down the plus bracket n minus 1 bracket, and then we put in our difference. So the difference between 11 and 23 is 12, and 23 and 35 is 12, and so on. So 12 is our difference. So next we simplify. We're going to bring down the 11 and the plus, and then we're going to multiply out our brackets. So n multiplied by 12 is 12n. And minus 1 multiplied by 12 is minus 12. So now we're going to simplify a bit more. So we can bring down the 12n. And 11 minus 12 is minus 1. So Tn, again, is equal to 12n minus 1, which is what we've worked out here. Question F. Which row has coins with a total value of 337 cent? So the first thing to note here is that we don't know if the row, which has a total value of 337 cent, is an even row or an odd row. So we're going to have to try with both. So let's start with odd. So if n is odd, so if the row that we're looking at is odd, so it could be the first row, the third row, the fifth row, the seventh row, and so on. So if the row we're looking at is odd, then row n has n 1-cent coins and n minus 1 5-cent coins. So we wrote this statement earlier on. So if n is odd, we'll have n times 1, so n times 1 plus n minus 1 times 5, so n minus 1 times 5, and it will be equal to 337. So we're going to multiply out our brackets. N times 1 is n, or 1n. N times 5 is 5n, minus 1 times 5 is minus 5, and that's again equal to 337. So we're going to simplify. N plus 5n is 6n, and the minus 5 will come over the equal sign and become plus 5. And 337 plus 5 is 342. So then we'll divide both sides by 6 to get the n on its own. So we'll have n equals 57, because 342 divided by 6 is 57. Now let's have a look if n was even, so if the row was even. So if n is even, row n has n minus 1 1-cent coins and n 5-cent coins. So again, we worked this statement out earlier on. So if n is odd, we'll have n minus 1 multiplied by 1. So n minus 1 multiplied by 1 plus n multiplied by 5. So n multiplied by 5 equal to 337. So we'll multiply out the brackets. N times 1 is n, and minus 1 times 1 is minus 1, and n times 5 is 5n. And again, it's equal to 337. Next, we'll simplify. N plus 5n is 6n, and then we're going to carry this minus 1 over the equal sign, it becomes plus 1. So 337 plus 1 is 338. Then we're going to divide both sides by 6 to get the n on its own. So we have n equal to 56 and a third. So 338 divided by 6 is 56 and a third, or 56.333, or 56.3 with a little dot on it, which is recurring, which means it's gone on forever. Now, 56 and a third is not an element of n, so it's not a natural number. It's not a positive whole number. And n has to be a whole number because we're talking about rows. So we've got the first row, then the second row, then the third row, then the fourth row. You don't say you have the 4.5 row or the 4.2 row or anything like that. So 56 and a third, there is no such thing as the 56 and a third row. There's the 56th row, the 57th row, the 58th row, and so on. But there's no such thing as the 56 and a third row. So therefore, n must be equal to 57. So therefore, row 57 has a total value of 337 cents. So if we went to row 37 and we added up all the coins in that row, we would have 337 cents in total. Part G. Find the total value of the coins in the first 40 rows. So if we took all the coins in the first 40 rows and added them together, what would we come up with? So we want the total value of the coins in the first 40 rows. So if we start with the odd rows, so row 1, row 3, row 5, row 7, and so on. So we're going to take the total value of the coins in those rows. So we've got 1, then 13, then 25, then 37. So we've got 1, 13, 25, 37. So we're going to use our SN formula from our formula book, which is the sum of series formula. And we're going to use this to work out the total amount if we were to add together all the rows in the first 20 rows. Because if we're interested in the first 40 rows, well, half of the first 40 rows are odd and half of 40 is 20. Now the reason why we're doing this, why we are only focusing on the odd rows, and why we're not using the sequence of 1, 11, 13, 23, 25, 35, 37 and so on, is because this is actually not an arithmetic sequence, and we can only use this formula with an arithmetic sequence. But if we only focus in on the odd rows, we do have a constant difference. we do have a difference of 12 each time. So we have 1 plus 13 plus 25 plus 37 ... So we use our SN formula, where A is equal to 1, the first term, D is equal to 12, the common difference, and N is equal to 20, because half of 40 is 20 and half of the rows are odd. So we have Sn equals n over 2, which becomes 20 over 2, multiplied by 2a, which becomes 2 times 1, plus n minus 1, so plus 20 minus 1, multiplied by d, which is 12. And we can't put this into the calculator all in one go, we do have to do it step by step, but we will end up getting 2,300. So if we were to add up all the odd rows up as far as what would be the 39th, because 40 is obviously even, we'd get 2,300. So now we're going to do the same thing with the even rows. And when we get our answer, we add them together and that will give us the 40 rows. So our even rows are the second row, the fourth row, the sixth row, and so on. So 11 will be our first term, then 23 will be our second term, then 35 will be our third term, because remember again, we want an arithmetic sequence, so we want the same difference. So we can't take all the numbers in a row, we have to just focus in on the even numbers, because we're using our SN formula, which is the sum of series formula, which can only be used with an arithmetic sequence. So the A is 11, that's the first term of the even rows. The D again is 12, we're going up by 12 each time, and the N is 20, because again, there are 40 rows in total that we're interested in, and half of 40 is 20, and that makes sense because half of the rows are even. So we use our SN formula, so n over 2 becomes 20 over 2, multiplied by 2 times a, which is 2 times 11, plus n minus 1, which becomes 20 minus 1, multiplied by d, which is 12. And again, we'll have to do this out step by step. We can't put it all into the calculator in one go, but we end up with 2,500. So, if we were to add together all the coins in the odd rows up as far as 40, we get 2,300. And if we were to add together all the coins in the even rows up as far as 40, we get 2,500. And adding these together, we get 4,800 cent. So the total value of coins in the first 40 rows is 4,800 cent.